Hello everyone, my name is Kunal Ghosh. I am the presenter of this talk, and Anaga Ghosh is right there at the back taking care of my daughter, as most of you have already seen it. So our company VLSI System Design is mostly known for its collection of videos. I'll show you a collage that we have prepared just a night before coming over here.
My name is Kunal Ghosh.
May I just interrupt here?
Yeah, sure. The way the engine works is it divides the entire circuit into 3 different models. This is how the box will look like. This is a shell script. If you see, there is a lot of things that is happening over here, and once it runs the synthesis, it will run the timing and then give you the timing results. All this entire information needs to be processed or converted into a format which is called as the SDC format. We need to be very careful with the clock because that's the one that can affect all your timing information. So the question is whether is there any inherent command to check what is the runtime, right? It looks over here to be a single bit, but in reality that's not a single bit. It's basically a burst netlist. So just give it a thought and see how does it go.
Yeah, so thanks Taswan, he just gave us a celebration. So this is what we, most of you must have got a picture of what we do. It's mostly on online learning, and while we do the learning, we promote open source tools usage. We get leads for open source tools, and I'll show you a way how do we do it and how it all started. So if you see over here, we started our website. It's called as VLSIsystemdesign.com in the year 2011, and this is how it looked like in the year 2011. So this if you see all this, these are all hand-drawn images that you see over here, and these images are mostly from the notes that I used to collect when I was studying in my college for post-graduation. So while that time I collected all these notes, and it was a 200-page book. So it was very difficult for me to manage that book and carry it over here and there. These were the notes that got my first job in Qualcomm. So this notes actually became hit amongst few students or few of my juniors, and so I thought of uploading these notes. These are very hand-driven notes, and it has got, these are the few clippings of what I'm showing. I actually have like about 1,000 images. That time I had about 1,000 hand-drawn images, which actually helped students to get placed in their, in the jobs and all. That was the criteria at that point of time, 2011, where people were looking for placements. But this looks to be a bit shabby for to take it forward. So what happened when I showed this particular website to, let's say, 10 people? Out of 10 people, 5 people actually entered into the website. They went through the website and they understood the concepts, and they understood things in a pretty better way, because it's all image. And out of 3 out of 5 actually got placed to several other companies. And that's how it all started. That's how I got my first 3 members for this particular website. So moving on, this looked to be a bit shabby to be presented to the countries which are outside India. So what we did was, we met a person. This is one of my first mentors. His name is Shrikant Jarchala. So we met one of our mentors. He told us that why don't you convert whatever you see the image as infographics. So infographics, it's most of you must be aware of what infographics is. It's basically, if you look into this particular image, if you look this image, and if you look these images from year to year, you see after every image there is one thing coming out. So from this image to this image, this is one thing that is coming out. From this to this, if you see, there is one title that is coming out. If you move from this over here, from over here to here, you see a bump coming out, and so on. So these are, so if you take a small concept, you take a small topic and split it into 10 different images. That's what we did. So that was the first thing that we did, and we uploaded it on SlideShare and our website, and we saw what's the response was, and we got a pretty good response. But still, if you see, these are like PowerPoint slides. It's just PowerPoint slides. It doesn't create an impact what we thought it should create. So what we did was, after we made all these images, we did a very simple change. So everyone is aware of the Khan Academy, Salman Khan, Sal Khan. Okay, Sal Khan. What he did was. He had a pretty simple logic. Make some videos which are like 10 minutes shorter. They are like not long videos. Make videos which are like 10 minutes, and use a black screen at the back to explain things. Now there is a science, there is a psychology that goes behind having teaching on a black screen. So what happens is, have you heard of the term basal ganglia? Anyone over here? Have you heard of the term basal ganglia? Okay, it's a small part of your brain that records what you have been doing till now. For example, if you wake up in the morning, you brush your teeth, and you don't even think about brushing your teeth. You just go. It's all reflexes that happens. You brush your teeth. You just don't think about it. So from high school till often graduation, we are been told to, or we are been taught on the black background, on the blackboard, and that things gets recorded on you tend to learn more better when you learn on a black background. So what we did, we converted all the images that we saw on the website into a black background, and that's how things look to be more attractive. And that was the philosophy that was followed by Khan Academy. Khan Academy teaches K-12 students and below. So we took that particular concept, and there is a good thing that Khan Academy does it. He teaches on live. He draws the figure on live, but for VLSI students it doesn't work. You need to have some images which are not hand drawn. You need some sophisticated images. So we converted all the images that you see over here as a black background, and after doing this, we made some short videos. So we launched 4 video courses, 2 free and 2 paid, out of which the signal integrity and the clock tree synthesis were the paid courses, and the VLSI essential concepts and the physical design flow were all the free courses. Now, once you make free courses or once you make paid courses, we should know how to sell. I had no clue how do I sell this particular thing to other people. So there should be a way that I should find students to buy these courses and try to sell them. So I went on moving ahead. I made these courses and went on to a Udemy. Udemy is a platform where anyone has heard of Udemy. I think most of you must have heard of this particular site like Udemy. Okay, so Udemy is like you can upload your videos over there. You can give a price tag, and then you can give discounts, and you can give all those offerings, and after that you will see students buying those courses, and they are actually enrolling. It's basically a platform where you can sell your things over there. Okay, so Udemy, there is one of the marketing guy from Udemy who helped me with some of the announcements. So what happens? Anybody knew that there were 2 kinds of announcements? One is the promotional announcements, and the other kind is called as the educational announcement. So there are actually 2 kinds of marketing channel that you can do to sell your product. So first of all, it's the promotional announcements, where you must have seen these kind of mails where you give discount coupon codes, where you give the coupon code saying that it expires in next 18 hours. These are called as the promotional announcements. So these are actually to sell your courses. Next is the educational announcements, which is the rate at which you can send the promotional announcements are like 2 per month. That's the typical rate that any marketing guy follows. And once you are done with the promotional announcements, we need to also talk about the educational announcements. So these are the kind of announcements where you write blogs. You write a lot of blogs, and the blogs over here, as per standard way to write the blogs, it looks something like this. It should be about 4 educational announcements per month, and you should talk about, and basically I talked a lot about the topic that I'm trying to teach. There are no marketing materials over here. There are no coupon codes over here, but these are like plain blogs where you talk about what topics do you actually teach on, or what topics you actually cover in your courses. So that's the educational announcements that we tried to follow, and it's like the rate that we followed was 4 educational announcements per month. So that actually creates a good impact, and once you try to show this, there are actually people who start noticing you, who start observing you, and then we actually get more number of enrolls there is a lot of conversion from the free course, from blogs to free course, and from free course to paid course. So that's how things got actually, that's how we got the visibility over here. And once we do that, we have to actually enter into the tool domain where people actually start using open source tools. So that was the challenge that we hit at this point of time. So next, what we did, we met a person. This is another mentor from my college. His name is Ashok Kalwag. So he was of the idea that we don't want only enrollment. Enrollment was not good enough. We wanted people to actually complete the courses and do some labs. So we designed a challenge at that point of time. That challenge is called as Blue Chip Design Challenge. So it basically works on different levels. So have you heard of the Blue Whale Challenge, like level 1, level 2? It's a okay. So what it does is, the Blue Whale Challenge, it was created by someone in Russia, some PhD student in Russia. It takes you to 40 different levels. It makes sure that you are completely engrossed in the game, and at the end of the game you achieve something which is which you didn't even think of, you could have achieved that thing. Similarly, what we are trying to do over here is, we are trying to do a blue chip design challenge over here. We have designed it, it looks something like this. So you start from the basic MOSFETs over here, you try to understand the basic MOSFETs, then you move on, you use your own built MOSFET, and you try to design some circuits over here, and you take your own designed circuits and you try to build from few more gates at this point of time. Once you do that, from this gate you move to some combinational IPs, you build your own IPs, and from this level you move to the level 5 where you try to design actual chip. So while students are actually engrossed over, okay, one more thing, at every level of this thing you will have you have open source tools for each and every thing over here. For example, you have ng Spice for this one. You have if you consider layout over here, so you have magic tool for this one. For this one you have some, there are a couple of tools. You have eSIM, or you have electric tools, which actually helps you to achieve what you see over here. So there are multiple tools, and at each point of time, at each levels over here, if you try to include the tools at this point, so people and the students are so much involved in using the open source tool. I'll show you in a minute from now how I actually did it. So people get so involved, engrossing in this particular tools and using this tool, so that they actually cover these levels, and they at the end design a chip with their own hand, and they don't even realize that they're actually designing a chip. So that's the flow, and this particular challenge was designed. We have designed this in 2015, and we have to still implement it, and we are waiting for some relevant courses to for some of the courses to finish. We want these courses to be finished, and then we can launch the blue chip challenge. It's mostly for students who are trying to learn the physical design and trying to get into the EDA field. So that was the blue chip challenge that we are trying to implement, and this is where we were till now. And just by showing this particular idea, we got lot of eyes from the semiconductor from the industry actually, who wanted to see what are we actually exactly doing, because this looks like a tool. It itself looks like a tool, but it's not a tool. It's just an idea which is being crafted using PowerPoint presentation. So but that's the idea. So once we did that, the only person in this entire semiconductor industry who understood actually what we are speaking was this guy, Mohammed Qasim. So Mohammed Qasim, he is actually the CTO of efabulous.com. It's again a site where people, where he encourages open source tool usage. So we talked a lot. He's again one of my mentors who explained me what exactly to do, and how do we achieve this particular challenge. So we had a talk like about a year. We talked about this particular challenge, and tried to find out what are the workarounds or what are things that we can do. And finally we came up with an idea, and the idea was something like this. If you want the students to actually get involved in using the tool, so this is what we did. You start from a design over here. So if you see over here, this is just a function, and I'm trying to explain how do you use magic, how do you do a custom layout. So that's what I'm trying to do over here. So you start from a design, you use the concepts of network graph, let's say PMOS network graph and the NMOS network graph. You use network graphs. Then you actually draw the Euler's path using the network graph that you have already built. Then after that, you just draw the stick diagram of this particular thing, and then finally when you have drawn the stick diagram, you use hand draw the layout using the design rules, or using the lambda rules over here. And then finally at the end, you make sure that this is being implemented using the tool. So the way the flow is, the tool is just the 10% of what you are trying to achieve. But the student, once he starts from this point, he gets so engrossed in this particular levels that he actually goes and downloads the tool and try to implement what you see over here. So this tool, magic tool, when I launched this particular course, this actually tool got a lot of interaction, a lot of attention, and there are too many downloads for this particular tool. And there was a point where I was acting as an application engineer between the users and between the person who has designed the magic layout tool. So I used to get some queries from my community. I used to talk to Tim Edwards, who manages this tool, and I used to take the report from him and pass it to the user. So I was acting as just like any EDA vendor AE. I was acting like an AE for the open source tools and for the users who are using the open source tool. So this was a pretty good concept where we actually got a lot of people. Now I have about 300 students who are actually using this custom layout tool, and we are interacting daily how to use the tools and all. So this idea went very good, and I got people I got students who are actually looking for courses which are like where tools are actually integrated inside the tool. So this is one of the concept that we did. We did a similar concept for another open source timing tool, which is Open Timer. It's an STA tool, and I'll talk a bit about that. Once we did that, so okay, another problem that the open source users, the people who are using open source, the problem that they face, that they don't know how to or they face issues while installing the open source tools on their laptops. That's what I have seen with my users. They ask me questions that we are getting this issue while downloading the tool, we are getting this issue while installing the tool. So what we did was we created a complete guide to install open source EDA tools. So for example, we have like 7 different tools what we started with. We have shown them how to install a synthesis tool called VLSI. We have shown them how to install eSIM. We have shown them how to install Open Timer. So we took the complete live installation. We created a videos where it says that how do you actually download Linux VirtualBox onto your Windows machine and how do you install the tool. So we actually shown the complete guide to open source EDA tools, and that's what people start. They say they start from this point, they install the tools, and if they face any issues, they actually I get some over here when I try to show them how to install the tools, I get some live errors, and even the students also get the live errors, and as a result of that they are able to solve the installation part. So it looks to be a very trivial problem, but it's actually a problem amongst the users the people whom I am teaching over here. Next, once you do that, so all this happened. So when I was in 2011, I was working for Qualcomm. At this point of time, I was working for another EDA company. So the problem that when you're working for an EDA company and parallelly you're releasing a course using an open source EDA tool, there is something called as conflict of interest. So that was the point where we had to go full time. I mean, we just left our job, and at that point of time, from that point of time onwards, we are doing this full time. And once we did that, next we met Tim Edwards, who looks into the open source EDA tool chain. So he is one of our mentors who explains or who helps us with the physical design tool chain or the physical design tool flow. So if you see, there is a poster in many of my courses. I've given him acknowledgements. If you enter this particular course, let's say custom layout course, you will see I've acknowledged him in this particular course. So he is being very helpful while designing and while making some notes on this particular course. And also tomorrow there is a poster presentation that I'll be presenting a poster over there. There you will see there are a lot of experiments that we did using Qflow, and Tim has been very helpful for helping me implementing all the entire poster and all the data that you see over here. So he has been a mentor over here, and the entire EDA tool chain, we are together working on a couple of designs where we got a lot of issues, and basically if you say he is the kind of R&D guy, and I was being the AE between the users and Tim Edwards. And finally, once we did with this kind of work, next we reached the finally once you implement your design, you need to test it, or you need to analyze it in terms of performance. So that's where Sung Wai Huang, I think Sung Wai Huang is the person who had presented last year in ORConf. He presented this new tool called as Open Timer STA tool, and he is our technical guidance and technical support for the STA tool. We again made a course on STA as well. It's called STA Part 2, where we actually teach how to do the different kinds of analysis, and then we install Open Timer. We show them how to use the Open Timer tool and how to do different kinds of checks using an open source EDA tool. And that's where these are the some of the strategies that we have followed till now. And then finally, and also there is the poster that we are going to present tomorrow. We have got some of the data which is being present in this particular poster has been contributed by Sung Wai Huang. So you might want to just come and have a look into the poster tomorrow. And finally, once we are done with all this, so currently now this is the current status. We have like about 15 courses, and we have about 13,000 plus students across 126 countries. And this is the average rating. If you see over here, this is the exact number that is like a week back. This is the exact number that we saw a week back. And the top locations are 47% are from India, 28% from US, 2% from Egypt, 1% from UK, and 1% from Canada. and currently right now we are at 126 countries with 13,000 plus students. Yeah, that's all I had. And finally now we are at ORConf. So after 7 years the journey has just begun. This is the entire, these are the pillars of where the company stands now, and we are now at this point of time, and this is just the beginning. So I hope to interact with you a lot based on the same concept, maybe video courses and all those things, so we can talk a lot about that. And that's all. So what next? The idea, the things that we're trying to implement in the upcoming years. Oh, you need to sign up on this particular website, so I get your email IDs. I can send you some promotional announcements. Yeah, thank you. Any questions on this one? This is me from India. Any questions? Yes.
Maybe I missed it. I don't recall seeing a course list and it sounds like you're building multiple courses, but
Yes.
do you have a list of courses that you've done so far, or are you still building them?
So I have.
What's available right now? This is my question.
Okay, so the question is, what are the courses right now I have available? So I have 15 courses. I have not printed the list over here. There are courses on clock tree synthesis, courses on signal integrity. There is a course on tickle scripting. There is a course on physical design flow. There is a course on OpenTimer STA tool, where I actually teach how to use OpenTimer. There is a course on magic layout, how do you do the layout, and there is a course on interview FAQs. I'll give you the list, entire list, maybe after this particular talk. Currently I have done 15 courses, and there are 5 courses in pipeline. And out of this, one is using there is one on synthesis. I have talked to, I'm in talks with Clifford, who is the synthesis tool. I don't know, I was searching for him, I didn't see him. So,
Yeah, I don't think he's here.
oh yeah. So I have talked to you over the emails where I'm requesting for your permissions to use Viosys as a synthesis tool as my course. So that's the next course I'm working on. And there is if you saw that blue chip design challenge, that's where we are trying to teach how to build a processor. So these are the 5 to 6 courses in pipeline. Yeah. So by the way, if you see over here, this thing, you might see who makes a course on how to install open source EDA tools, right? Even I thought so. This is actually not my idea. This is my wife's idea. She told me to make a course on how the installation tools, and I was like, why do you want to make a course on open source, how to installation tools? But if you see the highest number of course registrations that I have, that's on this particular course. So some things you don't argue with your wife, you just agree to them. Yeah. Yeah.
Okay, so are you alone or together with the wife responsible for the course material, or do you have other people working also? It means a lot of topics to cover.
Yeah. So the question is, do you have a team? So the question is, do I have a team or not? So I look into the making of the course. Anaga, who is the co-founder of this company, she reviews the course because she's from a non-VLSI background, and we are targeting students who are non-VLSI or who doesn't know anything about semiconductors. So she reviews all the courses and she pinpoints that where the basics are missing or where the connections are missing. So that I even cover those persons who have no idea about open source tools, who have no idea about semiconductors, because the way I think is it's from a VLSI background, it's like this, and the way she thinks it's like this. So we cover this kind of students also. So she's the reviewer. I make the technical support, and Tim Edwards and this guy Sung Wai Wang, they actually help me to design experiments and all those. So it's a community. It's an unpaid community where we are not hiring. We are mutually we work mutually together, just like people are working over here through mutual understanding. So he helps me with any technical problem with the STA tool, and Tim Edwards helps me with any problem with the Q flow or any questions on the magic layout tool, and she reviews it, and I make the courses. So I'm the labor, they are the bosses. Yeah.
Assuming you graduate from all of the courses, how do the students then go and turn out a
Yeah.
someone else's design. But have you figured out how to get them all the way to producing test chips?
Yes. So if you see this blue chip challenge, this one.
Yes.
Yeah. So I have a course. For example, I have a course on PMOS and NMOS, the physics of transistors. So they go through this course, they understand ngSpice and all those things, and there is a course on layout. So they build their own MOSFETs.
Yeah, but at the end, how do they get a tape out, get the chip fab and packaged?
No, fabrication level we haven't reached that step, because right now foundries are not ready to give us their libraries and everything. I talked to a couple of foundries, except Mohammad Qasim. He talked to XFab, and XFab is ready to share something, but that's too old. That's a 350 nanometer technology. I'm looking somewhere in 65 to 180. Fabs are not actually entertaining us to give their libraries. So right now I'm using OSU standard cells. That's an open source library. Right now I'm using that, and let's see. Maybe after this talk, I'm trying to. There are a few people in China who are. I'm talking to them. Let's see if I get something from them. If I get something from them, I'll try to use. I'll ask my students to use those things so that they actually get fabricated, at least in the Chinese semiconductor firms. Let's see how it goes. Yeah. So there are people who are coming forward, who even there are people who want these tools to come out, and they are from the fabrication industry. So let's see. We are still in talks. Yeah. And since we are very new, we are like over here it looks 2011, but I'm doing this full time since only this year, because there were conflict of interest and all. So right now I have to get into attracting the manufacturers. But definitely one day, maybe next year, you might see something taped. I don't know. We are just working hard towards it. Yeah. Any questions? Yeah.
I think you just made a point, the fact that our other halves put up with us doing this kind of thing. So I think a round of applause for your wife.
Yeah. So he said that we should. Can you tell her to? She didn't listen to you.
Oh, right. You deserve a round of applause.
Yeah. Any questions? Okay. Thank you. Thank you very much.